Hi everyone. Today what we are going to deal with, that is the resolution of a vector. So just before discussing about the resolution of a vector, think about one simple example. We have two vectors. Say it as this is the vector A, correct? And this is the vector B. So we have two vectors, vector A and vector B. So how to find the resultant of this vector? That we have already learned by shifting this vector, that is this is a vector A, the same vector I have shifted here without changing the magnitude and direction, okay, without changing the magnitude and direction. Now I shifted the vector B without changing the direction, parallel exactly. This is a vector B. Now we have to calculate the resultant vector. How to calculate the resultant vector? Just joining the tail of the vector A to the head of the vector B. So here we got what? The resultant vector R. So what we have done in this case, we have two vectors A and B. Now using these two vectors, we have made into a single vector as a resultant vector. Okay, with the help of two vectors, we made into a single vector. But in resolution of vector, what we are going to do here, we will have only one vector. Now we are going to resolve into two or more vectors. So single vector, we are going to split into two or more vectors, and that splitting is called what? Resolution of a vector. So just for comparison only, I gave this example. Here, with the help of two vectors, we have made into single vector. Now in the resolution of vector, what we are going to do here, we are going to split a single vector into its component vectors. Clear? Now let's see what is the definition of resolution of a vector quantity. It is the process of splitting a vector into two or more vectors in such a way that their combined effect is same as that of the given vector. So that is the definition for which one? Resolution of a vector quantity. Now let's discuss about the resolution of a given vector in different directions. Just imagine, see in the picture here, this is the given vector. Say it as R vector. Okay, a name is given the R vector. And nearby this one, there's another picture is here. In that one, there is a two vectors are there. We can say that these are the coplanar vectors. What we are going to do here, we are going to split this R vector in the direction of the given two vectors. In the given two vectors. So what we are going to do here, we are going to resolve the given vector R into two components. That is, one is in the direction of A vector and other one is in the direction of B vector. For that purpose, what we have done here, we have drawn here two parallel lines in the same direction of A vector and B vector. So this is the one line parallel to A vector, and this is a line which is parallel to B vector. Both vectors, if I am giving the name is here O, Q, okay, and this point as P, you can see here at the point P, these two imaginary lines are intersecting. Okay, now what we can write here, this can be written as a vector, we can consider this as lambda times A vector. What is that? Lambda times A vector. That means we are resolving this R vector in the direction of the given vector A. So this may be any magnitude. So we are multiplying with a non-zero value, that is lambda. Okay, it's a real number. Lambda times A vector. And here we can write here as a real number, say it as mu times B vector. Mu times B vector. Okay. So this is not the B vector. We are drawn here in the same direction of B vector. So, and we are going to resolve this R vector along B vector and the A vector. So this is lambda A vector and this is mu B vector. So we can give the direction as like this, the mu B vector. Now if you use the triangle law of vector addition, you see this one, we can write this equation as OQ vector, right, is equal to, OQ vector is equal to OP vector plus PQ vector. OQ vector is equal to OP vector plus PQ vector. Here we have already know the value here. What is OQ here? OQ is equal to R vector, which is equal to OP vector. What is OP vector here? Lambda times A vector plus mu times B vector. So what is the resultant vector here? R vector is equal to lambda times A vector plus mu times B vector. So what is the meaning in this case here? Just see this one. What is the meaning here? The given vector R vector is now resolved into two components. One is along the same direction of A vector and the other one is along in the same direction of B vector. So we have now resolved a single vector now split into two vectors. Okay, so it's already given only one vector, R vector. Now we have resolved into OP vector and PQ vector, but the combined effect is same as the given vector. Correct? The combined effect of these two vectors is same as the given vector. So this is the simple explanation for what resolution of a vector. Now let's discuss about the orthogonal triads of vectors. That is orthogonal triads of unit vectors, or it is also called the base vectors. So for that, you just see one diagram in this case here. You can see here in this diagram, it is given a Cartesian coordinate system. See in the diagram, a Cartesian coordinate system is given there. So you can see here all the positive axes are given there along x-axis, y-axis and z-axis. Now we are going to use here the term splitting of vectors or resolution of vectors. So maybe we can split the vector in the direction of x-axis, y-axis or z-axis. So we require this orthogonal unit vector concept. So what is meant by orthogonal unit vectors? So any vector, if you are resolving into components, just imagine if you resolve one vector into along x-axis, we can denote the direction of the given vector along x-axis with the unit vector called I cap. You can see in the picture I cap. Same way, if a vector component shows the direction along y-axis, we can represent it as what? J cap. Same way, k cap represents the direction of given vector, the component of given vector in the direction of z-axis. So I cap, j cap, k cap represents the direction of the given vector along x-axis, y-axis and z-axis. And these three unit vectors, I cap, j cap and k cap, are called orthogonal triads of unit vectors. It is also called what? Base vector. Now let's discuss about the resolution of a vector in a plane. So just imagine we have a vector is given. See, the vector is a vector. Okay, a vector is given, its name is what? A vector. Now we are going to resolve this given vector into its component vectors along x-axis and y-axis. For that, I'm just drawing here x-axis and y-axis. So this is the x-axis and this is the y-axis. In order to split this given vector into two components, which are the two components? One is along x-axis and other one is along y-axis. So what we are doing here, if you split this vector, just imagine this is the angle theta. So it can be resolved into two components. One is along the x-axis and other one is along the y-axis. Okay. So in order to represent this one, I can write here this as the ax vector and this vector is called what? Ay vector. So what we have done here, the given vector A is now split into two vectors. One is along x-axis and other one is along what? Y-axis. So here you can also say this one word. This is the projection vector of vector A along x-axis. And this is the projection vector of vector A along y-axis. So ax vector and ay vector is the component of vector A along x-axis and y-axis. Now what we have done here, we have split a given vector into two vectors. So this is called what? Resolution of vectors. Now let's give some name here. Say it as O, this is P, and this is Q, and this is R. By using parallelogram law of vector addition, we can write this equation as OR vector is equal to OP vector plus OQ vector. Two components, right? So what is OR vector? That is equal to what? A vector. So I can write here A vector is equal to. Now what is OP vector? OP vector we have named as AX vector. That is A subscript X vector plus what is OQ? OQ is given the AY vector. What we are discussing here, the given vector A can be resolved into two components. One is along x-axis and other one is along what? Y-axis. So this is a general equation for resolution of a vector, splitting the vector into x-axis and y-axis component. Now we have already learned how we can write here AX vector. AX vector can be written as modulus of AX vector into I cap. Correct? The same way, AY vector can be written as modulus of AY vector into J cap. What is the meaning? AX vector is equal to modulus of AX vector. That means magnitude of this one into which is acting in which direction along x-axis. AY vector is equal to modulus of AY along which axis? Along y-axis, representing unit vector about j cap. So we can substitute in this equation here. So we can write here A vector is equal to AXI cap plus AY j cap. AXI cap plus AY j cap. So this is the equation for vector A in terms of rectangular components. Now how to calculate the magnitude of this given vector? For that, you just take this triangle. Say it as the triangle OPR. Here resultant one or the given vector A vector making an angle theta with the x-axis. So you can calculate here what is the cos theta is equal to. Cos theta is equal to adjacent side divided by hypotenuse. Correct? So what is the adjacent side here? Adjacent side here you can take the magnitude AX. So we can write here AX divided by what is the hypotenuse here? Magnitude is equal to A. So AX divided by A. So we can write here cos theta is equal to AX by A. So we can write here A cos theta is equal to AX. Okay. So you got here AX is equal to A cos theta. Say it as equation number 1. Same way, you find the sine theta from the same triangle. You can see here sine theta is equal to opposite side. What is opposite side? Is same as what? AY. So we can write here AY divided by hypotenuse is same as what? A. So we can write here AY is equal to A sine theta. Equation number 2. Now square and add these two equations. We can write this equation as AX square plus AY square is equal to A square cos square theta plus A square sin square theta. Now AX square plus AY square is equal to A square into sin square theta plus cos square theta. What is sin square theta plus cos square theta is equal to 1. So we can write this equation as A square is equal to AX square plus AY square. So what is the resultant of A? Square root of AX square plus AY square. So this is the way to calculate what? Resultant vector. Okay, or the magnitude of the given vector A. Now you can also calculate the direction of the given vector with x-axis. So how you can calculate here? Find the tan theta. If you calculate the tan theta here, tan theta is equal to opposite side divided by adjacent side. What is opposite side? AY. So you can write here AY divided by, what is adjacent side here? That is AX. So what is a theta? What is a theta? Angle. Theta is equal to tan inverse of AY divided by AX. So this is a way to calculate what? Angle, right? The angle which you're making with the x-axis. And the same way we can also calculate what? The magnitude of given vector. So in this class, what we have done here, we have split this given vector into two vectors along x-axis and one is along what? Y-axis. Also, this splitting of single vector into two or more vector is called what? Resolution of a vector. So we will be discussing, we'll be continuing this class later. Okay, thank you all of you.